Okay, so today we're going to take the factoring that we've done the last 2 days and now turn them into equations. So now saying things like x equals blah, blah, blah will actually make sense, whereas the last 2 days it did not, because expressions can't be solved, they can be simplified. Here we're doing equations which can be solved. So let's start with something fairly straightforward. Whoops, that's a 7. Okay. What's the first thing you notice?
3x squared.
I'm sorry?
3x squared.
Okay. Therefore, what do you get out of that? Jill?
If you move the equation or if you move the 4 onto the other side, then you can set it equal to 0.
Good. We'll get to that in a second. What else do you notice? Let's start with the basics. The title of the section is Quadratic Equations. Therefore, every time we solve one of these, we should get how many answers? 2. There is no exceptions to that rule. Even when we get problems where it's no solution, there are actually two solutions. We're just not going to do the math to find those 2 solutions. They're called imaginary solutions. So, Jayla, you want to set this equal to 0?
Yes.
Okay. So I would get 0 equals 3x squared minus 21. Okay? Jalen, keep going. Now what?
Then you can factor out 3.
Uh-huh. What's 21 divided by 3?
7.
Okay, just checking. Now what? Okay. I'm going to do this. What allows me to do that? You can't just randomly get rid of numbers. We learned yesterday you can't just randomly make that GCF disappear. Wait.
Zero product property?
Say again?
Zero product property?
Which means what?
So, like, because there are 2 things that are being multiplied to 0, one of them has to equal 0, so it's either 3 equals 0, which is not true, so it can't be that. So then x squared minus 7 equals 0.
Perfect. Good. Okay. Which means, from what she said, that x squared minus 7 equals 0. Which is what I get when the 3 goes away. How do I solve that? What are we missing, Matt?
Is the right-sided equation?
I got it right-sided, 0. So what are we missing that's in a standard quadratic?
Oh, another x.
Good, we're missing the b term.
Yeah.
So how do you want to solve that?
The way I remember is just you add 7 and then square root it, but then you're going to get a bad number.
Bad number, like a delinquent number, like a number that lights fires in the garage when mom and dad aren't home and steals packs of gum from Walgreens, that kind of bad number? Okay, all right, I'm intrigued to see what kind of bad number is going to show up here. Okay, so now what do? I move the 7 to the other side.
You square root both of them.
Square root both sides. You undo squaring by taking the square root. Matt, what's the square root of x squared?
X.
What's the square root of 7?
2.6.
No, I want exact answers.
Plus 100 square root of 7.
Good. We're going to leave it like that. And we're done. Which one of those is bad?
Decimal.
Decimal's bad.
Yeah.
Good. What else would be a bad number?
Fractions.
No, fractions are okay. We'll get some fractions.
Negative number.
Be a little more specific.
Negative decimal.
No, negative decimals are okay. Beautiful.
Yeah. Oh.
So let's suppose in this problem that instead of this being a minus, it was a plus. So this would be plus 7. I can use a different color to illustrate that. Let's suppose this was plus 7. When I move the 7 to the other side, I have a negative 7. And taking the square root of -7 doesn't make any sense for us. So that would seem that that violates our two solutions rule. It does not. The square root of -7 for us doesn't work. Later on in different classes, you will find out it does work and there are still two answers, but we don't want to deal with it. Okay? Good. Now, if we go back to the very beginning, you know what? Hold on. Let's just move on to a second problem. And I can illustrate the point I was going to make just now by doing a different problem here. We're talking about two different ways to solve this one. What?
Well, I mean, couldn't you, subtract?
If you say Deadpool, Emily will stab you in the back of the head with her pencil.
Say that.
I kind of want to say it, but you could subtract 25 on that side. The
From
right-
that side?
Right side. Yeah.
What'd you say?
Why not the left side?
Why not the left side?
Oh, wait, both sides.
Why?
Wait. Because what you do one side, you have to do the other.
Perfect. Basic rule of algebra, whatever you do to one side of the equation, you have to do to the other side. So if he wants to subtract 25 from both sides, we can do that. We'll go down this rabbit hole and see where it takes us. Okay? What next, Tom?
Could you foil it?
Sure, I can foil that.
How'd you do that so fast?
I'm a trained professional.
And then
Squaring a binomial. Remember, square the first term, 25x squared. Multiply the two terms together. 5x times -1 is -5x. Double it. Gives you the b term. Square the last term. It is not 25x squared plus 1. You got to have a b term in there. Put your hand down. Now what?
you combine like terms.
Combine like terms. I like it.
And you have to get two equations, right?
Two
Or
equations?
Not two.
Two.
Yeah, two of those little things.
What are them little things called?
Well, I know what you say like quantity of. No. A.
A,
E.
E,
F.
F, as in ferret? I just didn't hear you. I didn't know if you said S or F. F as in ferret?
S.
S as in salamander.
Yes.
Yes as in yes.
No. Yeah.
Or yeah, but there's no S in yeah.
Yeah. T.
T as in turtle?
Yeah.
Oh,
Okay.
I know what it is. I don't even know what it is.
Shh.
M.
M as in mongoose?
Yes.
The guess.
Oh.
Oh.
R.
R, good. I thought you were gonna say A as in team. Go team! That's what it is, team. We're gonna break that into some teams.
I already said A, so I probably would have said A though.
If you got there.
Okay,
So you need two terms.
Two terms.
Equal to 0.
uh-huh.
Okay, this part I'm iffy.
It's okay. Worst thing that happens is you drive the bus into a lake.
Okay. Can I call for help on this one?
No.
Call a friend.
So you need two things that multiply to get. No, two things that add to.
Oh, whoa.
Eliminate
Let's
two
start with
X's.
this. How are you gonna break up
Two
25x squared?
Can you do
You only got two choices.
5 times 5?
Is that the one you want to use, or you want to use
Yeah,
the, what's
sure,
the
I'll
other?
use 20.
What's the other choice?
25 and 1.
But you want to do 5 and
Yeah,
5.
I'll do
Okay.
that.
All right. Good. It's a good start. I hope.
And then you need,
Hold on. Let's talk about the signs. Plus plus, minus minus, minus plus.
minus plus. Right?
Huh?
Yes. Then you need two things that add up to 10. No. Yes.
Maybe.
You're like shaking your head. So
I'm enthralled.
I don't know.
Deadpool. Oh, sorry. Just wanted to throw that in there.
It's actually really good.
Okay. So. Yeah. I'm gonna call for help now. Can I call for help now?
No.
Could you do like -6 and -4?
-6 and +4. Well, the F is taken care of. The O is taken care of. Does the OI work out? This is 20x minus 30x is 10x. Good. Now what? Question? No? Good? We got more hands up. Yes?
Couldn't you just?
Is not a good way to start a question. Start over.
Okay, so could you square the x minus?
Wait, wait. Let's finish this first.
Okay.
Read it.
Oh, instead of -6 and +4, can you do -12 and +2?
No, because the OI wouldn't work out. And the O would, but the OI doesn't match. Okay. Joey, back to you since you started this mess over here. What do I do next?
You have to make them set them both to 0.
That's a 5. So x is equal to 6/5 and x is equal to -4/5. Two answers.
Add numbers.
Okay. Numbers are fine.
I don't like them. I don't care if you like them or not. Oh, he doesn't care. Yes, they do.
There is, however, were you gonna say something? Oh, I thought you were talking. There is, however, a different way to. Yes, Simon?
Can we just square root the top to just get rid of one of the 5?
It's funny you mentioned that. There is another way to do this problem, and I don't necessarily know if it's better. It's just different. There's nothing wrong with what Tom led us through. It worked out just fine. Move everything to one side, square that monster out, factor it again, set each of those equal to 0 and solve. However, as Simon mentioned, I could take the square root of both of these sides, and I would get 5x minus 1 equals, no. And? Is that it? No. Plus or minus 5. Now what, Simon?
We have to move. Don't we have to move the 5 to the other side?
You can choose to branch it into two different equations now, if this confuses you. You could do 5x minus 1 equals 5 and 5x minus 1 equals -5, or we could solve it as one big equation. Which one would you prefer?
Can we split them so we don't?
We can do whatever you'd like.
I would like to split them.
Okay, so we'll do one first. Ooh, same. However, if you want to solve it as 1, then you just have to leave the plus and minus in there. So it would become 5x equals 1 plus or minus 5. Divide both sides by 5, and I get 1 plus or minus 5 divided by 5. This is not an acceptable answer, but you do a little bit of math there. 1 plus 5 is 6 divided by 5. Oh, there's the 6/5. 1 minus 5 is -4 divided by 5, -4/5. Either one, I don't care. Both the black and the red are viable solutions to solving this problem. And you can argue all day long which one you like better. Doesn't matter to me. This, by the way, is called the square root method. The thing that people screw up on all the time is this business here. You have to remember that when you take the square root of a number solving an equation, it has a positive component and a negative component. Let's do one more example here. This will be number 3, I believe. Tricia, what do you want to do first?
Add negative 13x squared to both sides.
Move this guy over here. Since I start with an equation, I have to have an equation every step of the way. You can't just magically make the equal sign disappear, and it has to be equal to something every time. All right, what next?
Well, you can't factor it because there isn't a GCF. Actually, yes, you can. You can factor out x.
Beautiful.
And then you factor it, so you have
Which one do you want to use?
3x and 2x.
All right, let's give it a shot, see what happens. Well, that's easy. We just got to figure out where to put that stuff, right? Okay, what do you want to try?
Plus 5 and then minus 1.
Plus 5 minus 1?
Yeah.
Okay, so the f is good, the ol is good. This is 10x minus 3x. Nope, nope, nope.
Can we work the other way around? So
Sure.
minus 3.
So we'd have the 5, switch it so they'd have a 5 there and the 1 there. Which one's positive, which one's negative?
Positive and negative.
Other way around.
Negative.
Because we want the positive to be the bigger number, so this has got to be, this is going to give me the 15.
Okay.
So there's the ol, and the oi is 15x minus 2x, 13x. Good. Now what?
Then you solve it. So then you get 3 answers.
3 answers. Why 3 answers?
Because the x, right?
Yeah, good. It's a cubic. This is not a quadratic, it's a cubic, so therefore we have to have 3 answers. If we had a quartic, you'd have 4 answers. We should get 3 answers out of this. Even though we took the cubic and the first thing she did is reduce it into a linear term times a quadratic, we're still going to get 3 answers. How do I find the 3 answers?
So the first one is x equals 0.
Good. That comes from this. X equals 0. Done.
And then you set up 2 equations, so you'd have 3x minus 1 equals 0.
Uh-huh.
And then 2x plus 5 equals 0. And then solve them. So you get x equals 1/3. And then you get x equals 5 or 2. Yeah, negative 5.
Yeah. Okay, 3 answers. Good. So there are some basic rules that hold true regardless of what we're doing. You have to have the same number of solutions as the degree of the original equation. That's a cubic, 3 answers. Quadratics, 2 answers. Whatever you do to one side of the equation, you have to do to the other side of the equation. If you take the square root of one side, you got to take the square root of the other side. And the third thing is when you take the square root of a number, solving an equation, you should get a positive value and a negative value. If you get done solving a quadratic and you only have one answer, you may have made a mistake. Even something as simple as this, it would seem that I only get one answer here. X would equal 1. However, it's kind of a gray area that you actually get the same number twice. Okay, because this is the same thing as x minus 1 times x minus 1 equals 0. There's one answer, there's the other answer, they just happen to be the same thing.
You write it both times.
Yeah.
Yeah.
I would. I don't know if that's proper math, but I would, just to show that there's two answers to the quadratic. Okay, we good? So again, just taking the factoring stuff we did yesterday and turning them into equations and solving them. Okay. Remember to look for a GCF first, because it's going to make your life a lot easier. Like she said, we can't factor a cubic. We haven't talked about factoring a cubic, but when you pull the GCF out here, it turns it into a linear term times a quadratic term. Okie doke. Let me stop this.